Timeless concepts from Physics Helpline. In this video tutorial, we will discuss a multiple choice question on the charging of a capacitor network. The question is as follows. Read the question carefully. Two capacitors C1 and C2 are connected in series across a 200 volts DC supply. It is observed that the voltage drop across C1 is equal to 120 volts. Then a 2 μF capacitor is connected in parallel with C1. Due to this, it was observed that the potential drop across C2 was 160 volts. From this given data, we are required to find the values of C1 and C2 in microfarads. The circuit is shown in the figure. Let the potential drop across capacitors C1 and C2 are V1 and V2. Since they are connected in series across a 200 volts supply, we can write V1 plus V2 is equal to 200 volts. It is given that V1 is equal to 120 volts. Therefore, V2 must be equal to 80 volts. Now, let the charge on capacitor C1 is equal to Q1 and that on C2 is equal to Q2. Since they are in series, therefore, they must be equal. Therefore, we write Q1 is equal to Q2. But Q1 is equal to C1 into V1 and Q2 is equal to C2 into V2. Therefore, we have C1 V1 is equal to C2 V2. Putting the values of V1 and V2, we get 120 into C1 is equal to 80 into C2, which gives C1 is equal to 2 by 3 into C2. Now, a 2 μF capacitor is connected across C1. Therefore, the capacitance of the parallel combination becomes equal to C1 plus 2. Now, let the potential drop across the parallel combination is equal to V1 dash and that across C2 is V2 dash. It is given in the question that V2 dash is equal to 160 volts. Therefore, V1 dash must be equal to 40 volts because V1 dash plus V2 dash must be equal to 200 volts. Now, let the charge on the parallel combination is equal to Q1 dash and that on C2 is equal to Q2 dash. Since they are in series, we can write Q1 dash is equal to Q2 dash. Now Q1 dash is equal to C1 plus 2 into V1 dash and Q2 dash is equal to C2 into V2 dash. Putting the values of V1 dash and V2 dash, we write 40 into C1 plus 2 is equal to 160 into C2, which on simplification gives C1 is equal to 4C2 minus 2. From equations 1 and 2, we get 2 by 3 into C2 is equal to 4C2 minus 2. Multiplying throughout by 3, we get 2C2 is equal to 12C2 minus 6. On simplification, this gives C2 is equal to 0.6 μF. Therefore, C1 is equal to 2 by 3 into C2, which is equal to 0.4 mu F. Therefore, C1 and C2 are 0.4 and 0.6, which is the answer to the question. Therefore, the correct option is B. This completes the answer to the question. Thanks for watching. If the video is helpful, then please like, share and subscribe.